Hi, today we'll be looking at some applications of the motion detector by looking at how it can be used in three different experiments. The three experiments are 1. Solving for the angle of an inclined plane, 2. Testing for the conservation of energy, and 3. Solving for force using F equals ma. The motion detector will be our main vernier apparatus in all these experiments. We won't go through the experiments in detail. However, after having looked at this video, you'll have a better understanding of how to use a motion detector after you've seen how they can actually be used in these experiments. So let's begin. The first experiment we'll take a look at is solving for the angle of an inclined plane. Place the two ends of a track at different heights. You can use one or more thick books to do this as we did here. Connect the motion detector to a LabQuest and place it at the higher end of the track. Adjust and straighten out the sensor so that it is parallel with the track, and make sure that the detector is set to cart mode as seen here. Attach a motion detector reflection flag to the cart that will be rolling on the track. While the motion detector can still detect a car without it, this could increase the accuracy of your data. Place the cart on the track and now you're ready to collect the data. Zero out your sensor. Make sure position is set to 0 when the cart is at its initial position. Once it's zeroed out, start collecting data by pressing the play button on the bottom left corner. Let the cart roll down the plane, and you have your data. Now, this is the important part. There are the position and velocity graphs of the cart that the motion detector collected. Lots of stuff can be analyzed using these graphs. Try to think of all the things you can know from these graphs. For instance, looking at the position graph, you can tell when the car started and stopped moving. Looking at the velocity graph, you can tell that the car had an increasing velocity. But how about acceleration? Well, all you really have to do is highlight the portion of the cart's motion as I did here. Click Analyze, Curve Fit, and Velocity. Choose a linear fit and you'll see that we get a constant acceleration value. Using this value, we can use trigonometry to solve for the angle of the incline of the plane. But that process doesn't really involve the motion detector, so let's move on to our second experiment. Our second experiment involves using the motion detector to check for the conservation of energy. The setup is the same as our first experiment, except for that this time, the track is on a flat plane surface. We'll also be using the bumper launcher kit and have a hoop attached to one end of the cart. Again, zero out the sensor. Then we press play to start collecting data. We'll manually make the cart move, and the elastic hoop attached to the cart will make it bounce back once it bumps into the corner. The velocity of the cart, recorded by the motion detector, will be useful in allowing us to make an analysis of the energy of the cart. Using the equation for kinematic energy, 1/2 mv squared, you will be able to see through the data collected by the motion detector of whether or not the energy was conserved in this experiment. If it wasn't, it could lead to further discussions about energy, where the energy was lost. But let's stop right there and move on to our third experiment. In our third experiment, we'll be using the motion detector to see the relationship of F equals ma. We'll be using a second card that has the function of providing an impulse through this projector. Place the second card and the green card that you want to project on the other side of the track, opposite of the motion detector. This time, we'll not only zero our motion detector in our card's current position, but also select reverse. This makes it so that the position recorded reverses in direction. Start collecting data by pressing play, and project the car by pressing the button on the other car that delivers the impulse. When another person stops the moving cart, our data is complete. Open up a new trial. This time we'll essentially repeat the experiment, but with additional masses attached to our moving cart. From our prior knowledge of F equals ma, we can predict that the change in velocity detected by the motion detector, otherwise known as acceleration, will be smaller for this trial as the same force will be imparted on a heavier mass. If you want to check this for yourself, repeat how we found the linear acceleration value in our first experiment. Yeah, and so these were 3 applications of the vernier motion detector. Hope it helped, and we hope you enjoy your physics class. See ya.